started. Okay, so we're gonna have a quicker day today. I will make up whatever we don't get to on Thursday. I've also started, just in case it helps anyone, putting the learning objectives down. You don't have to write them down. Everything will be available to you, either in your textbook or on the PDF stuff. So today we're going to talk about calculus of vector valued functions. Second. So you can see here we have the definition. So the derivative of a vector valued function r of t is r prime of t, and then the limit is given. So we're going to use this formula. I'm not going to read it to you guys. You guys should know how to read all of that. So we're going to work with this. We're going to do an example. Those of you that take handwritten notes, I would recommend, if nothing else, to write down your definition. At least this part would be that would be important. And then if you feel so inclined, you could write this part. But I mean, at the very least, you should have this guy right here. Right? This section's super quick. It's only 10 slides. Right? You know what? Let's let the last person in before we do our next. Seth was already here. Must have gotten kicked out. Okay. So finding the derivative of a vector valued function, we're going to use the definition to calculate the derivative of the following function. So we know that we're going to have r prime of t, and that is the limit change in t to 0, and r delta t minus r t over delta t. Okay, so let's work this out. Limit and I have 3t plus delta t plus 4 I minus, and I will tell you guys, it used to be like a running joke that sometimes you would have to do calc problems like landscape style. Some of these are definitely super long problems. I think I gotta scoot it over. Hold on. 4t plus 3j all over. All right, then we're going to work through some distribution, cleaning it up a little bit. So we'll have minus. So that's coming from that right side. They're bringing their terms together. Parentheses, parentheses. Okay. 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 Almost done with this really long problem. Okay. So if we are approaching that at 0, then our answer here will be 3i plus 2t minus 4j. Okay. All right. And then you can see a little bit lower down on the slide, we have theorem 3.2, differentiation of vector valued functions. They give it to you for f, g, and h being differentiable functions of t. And they kind of give you like the generic form of that. This section has a lot of notey type things and not so many examples. Okay. So here's some properties for theorem 3.3, properties of the derivative of vector valued functions. They give you the scalar multiple, sum and difference, scalar product, dot product, cross product, and chain rule. You don't need to worry about writing those down right this second. You want them a little bit bigger, I can make them bigger. I would just, if I were you guys, I would just deal with those later. And whatever examples we go over about them, we can always go back. So I would definitely write these down at some point. If you're a fan of note cards, I would recommend the note cards. Okay. So I just wanted to give you guys an idea. You do not have to write this down by any means. But your textbook does show you some proofs. There are some proofs that I think you should at least kind of get the idea of where they're coming from and how they're finding it. I'm not going to make you guys do any proofs. No, I'm not going to make you guys do any proofs. I was slightly considering maybe it being a bonus question, but most people would just root memorize it, so don't worry about it. But I did want to bring your attention to this. This is also in the textbook. Oops. And I think it is the proof to one of your, might be a proof to one of these. I think F of T, U of T. F of T, U of T. Guess not. Anyway, so there are a lot of proofs in the textbook. I recommend you read through them, just because I think that will be a good idea for you anyway. So the next example we're going to do is using the properties of derivatives of vector valued functions. Given the vector valued functions, calculate each of the following derivatives using the properties of the derivative of vector valued functions. Okay, so we're not going to squeeze this onto one thing, so don't be scared. We're going to do it on two different slides. So the first one we're going to do is A here. So part A, we'll probably go down and then up. So we are looking at the rule where it's d over dt r of t dot u of t. So then we're gonna do r prime t dot u of t plus rt dot u prime of t. Okay, so we're gonna have 6t plus 8. That is a t, not a z. Crap. I wasn't paying attention. They just went ahead and started doing stuff. Apologies. I was just gonna write it all out for you. So 6i plus 8t plus 2j plus 5k dot t squared minus 3i plus 2t plus 4j plus t cubed minus 3t. Okay. All right. Unfortunately, there is a lot here, so it's not going to fit on the same line. So this is the first line. Okay. So plus, and then we'll have 6t plus 8i plus 4t squared plus 2t minus 3j plus 5tk dot, and now we'll do the derivative of this one. So we'll have 2ti plus 2j plus 3t minus 3k. All right. Equals 6 2t.
That'd be 3t squared. I'm sorry to interrupt. 3t squared minus 3k.
Yep. Thank you. Sometimes the tablet pen is just very finicky. Also, I probably forgot it in writing very quickly. So thank you for the catch. You guys don't have to apologize if you see an error. Just let me know. I'd rather you tell me about it than forget about it. Okay. Plus, do you guys want me to squeeze it in down here or go above? You want me to do a line above? Are you okay if I do this? Yeah. Let's look at this very long. Squared plus 2t minus 3 is plus 5t cubed 3. So then our overall answer, finally done with it, is going to be 20t cubed plus 42t squared plus 26t minus 16. Oops. That is the solution to part A. Okay.
So my only question on this then is where do the I, J, and K go?
So I feel like they probably just changed the form on us.
Because I think we would still need those coordinates since it's a vector, right?
That makes sense to me. They did drop them though.
Hmm.
I will find out for you.
Okay, thank you.
It may be in the textbook, but I will find out for you anyway. And then if I don't bring it up next class, then I will email you. I will take a look for you. Okay. Done with attendance. All right. So where did my well, that's not happening on one slide. I don't know what I was thinking. We're just gonna add a slide in here. Simple. I'm gonna go steal that question though. Okay, we'll write it down. All right, so part B. So the first thing we have to do for part B is adapt the property for V for this problem. So we're going to be looking at d dt u of t cross u prime of t is going to be equal to u prime of t plus u prime of t. Recall that the cross product of any vector with itself is 0. Furthermore, u double prime t represents the second derivative of u of t. Okay, so the first part will be 0. Okay, so u double prime t. So the determinant or the derivative of u prime t. So then we'll finally shove it in. It'll be 2ti plus 2j plus 3t squared minus 3k. And that's going to give us 2i plus 6tk. Then they say, therefore, zero plus t squared minus 3i plus 2t plus 4j plus t cubed minus 3t k cross 2i plus 6t k. And then we're gonna have a fun matrix. I, j, k, t squared minus 3, 2t plus 4, t cubed minus 3t. I'm gonna spread these out a little bit. And then 2, 0, 6t. That's gonna give us 6t to 4i minus 6t t squared minus 3 minus 2 t cubed minus 3t j minus 2 times 2t plus 4k. And if you work some math magic, you end up with a final answer of 12t squared plus 24t I plus 12t minus 4t cubed j minus 4t plus 8. Okay. Ah, great job, Romeo. You are correct. Yes. Back to those pesky definitions. Excellent job. Tiffany, were you able to read that?
Yeah, thank you. I just had one other question on this one,
Sure.
because I didn't take down the properties. So the first step of the cross product when we're doing a derivative is similar to the chain rule?
Yeah, I'm pretty sure.
Okay.
We'll double check with that right here.
Yep. Okay.
Yep.
Thank you.
You're welcome. And thank you, Romeo. Because the joys of being able to sit there sometimes and like run something through your mind. I super appreciate the assist. That was a great answer. Okay. So here's some more definitions. I will try to get this so you guys can see these at least, and then it works better once this little slidey thing is not present. So give me a second to make it so you guys can see each of these for a minute, and then I'll fix it again. So the next definition we're going to talk about is if we let C be a curve defined by a vector valued function R, and assume that R prime of t exists when t is equal to t sub 0, a tangent vector v at t equal to t of 0 is any vector such that when the tail of the vector is placed at point r t of 0 on the graph, then the vector v is tangent to the curve c. So we have a nice little, I'm going to do that, but I guarantee you it's going to stay there when I move this. Probably. Yep. Apologies. So you're going to want to write that down right there. And then you have a nice little warning tag. And then let me get this to go to the back. Okay. So then the other little part here is tangent vectors and unit tangent vectors. So recall from derivatives that a derivative at a point can be interpreted as the slope of the tangent line of the graph at that point. So we want to consider r of t cosine ti plus sine tj. The derivative then would be r prime negative sine ti plus cosine tj. If we substitute in the value of t equal to pi over 6 into both functions, we would get the following. Okay, and then they give you a nice little graph. So you don't have to worry about actually doing this problem, but I just wanted to give you guys an idea of, I thought it was a good idea, a good idea to get your minds flowing in the tangent universe. So we do have a more trig-based example coming up, so that's why I wanted to give you guys that. All right, so did I split these? Not, but I think I can fit them both together. So, all right. So the first one says, find the unit tangent vector for each of the following vector valued functions. So part A, we're going to try to do part A on the left side here, and we'll do part B over here if we can fit it. All right. Luckily, we have some slides to play with if we can't. So the first thing says r of t is equal to cosine ti plus sine tj. So our first step is going to be doing r prime of t. So that's going to give us a negative sine t plus cosine tj. All right, so the second step is going to be the absolute value of that, which will be the square root. Man, all these people getting to play cool games. We got to be doing work. Sorry. And that is equal to 1. So then here's your third step. T of t is going to be r prime of t over the absolute value of itself. So negative sine t I plus cosine t. Well, that is, wow. That's kind of impressive for me. Took my dyslexia to a whole new level there. So then that gives us an answer of negative sine So for that one, it just happened to be the actual first step answer, but that was probably a fluke. So don't get comfortable with that. But okay, so the next one, first thing we're gonna do, we're just gonna keep doing them in those steps. So we're gonna do u of t. So that's gonna give us 6t plus 2i minus 12t squared j plus 6k. All right, then we will find the next piece. So I called that an absolute value earlier. I'm sorry. You guys know it's not. You can blame mathematicians for having stuff that looks so similar. Okay. Squeezing all this stuff in is gonna be fun. 2 to the 4th plus 36t squared plus 24t plus 40 is 36t the 4th plus 9t squared plus 6t plus 10. Okay. All right. Third step, we're going to do that t of t again. As a u, not a v. All right. So u prime of t over its magnitude is going to be, we will write it out. And wish I could copy and paste that. I bet you there's a way, but I'm not going to worry about it right now. So then we have a very grossly long answer. It's just basically taking the pieces apart. So we would end up with 3t plus 1 over 36t to the 4th plus 9t squared plus 6t plus 10i minus 6t squared over 36t to the fourth 9t squared plus 6t plus 10 plus 3 Okay. All right. So, personal opinion, if you get to the first part and you don't feel like, um, if you wouldn't do the whole bigger answer, if for whatever reason you felt a time crunch, what have you, um, I'm probably okay if you tell me off to the side there's a divisor of 2 and you just don't feel like writing that. I mean, it's just very, very long. If you want to be most correct, obviously you guys can see the most correct answer there. But in all reality, they're equivalent answers. So if you wouldn't see that the 2 was in there or you didn't want to pull it out, I'm okay with that. But whichever answer there you would want, obviously I would say for an exam, try to go on your best answer there. Clearly, if you're doing the homework and you're maybe not seeing why you're not getting the right answer on something like that, that could be the possibility there. You might need to just spread it apart. All right. We have another very large definition here. I'll give you guys some time to write it. May need another slide potentially. And okay. All right, so we have some integrals. It gives you the definite integral, and then they give you the forms. There's a couple of forms, so I would say that that's a very important slide. So I would just make sure you know all these. Like I said, you don't have to write it down right this second. We're gonna do some examples. I think I can. Yep, that's what I should have done last time. Okay. We're just gonna give ourselves the extra room that I know we're gonna need. Yeah. All right. So part A, first thing we're gonna do is we are gonna use the first part of the definition of the integral of a space curve. So we will have the integral 3t squared plus 2t dt I plus the integral of 3t minus 6 dt j plus the integral of 6t cubed plus 5t squared minus 4. Okay. Oh, I forgot to squeeze in my dt there. Okay. And then we just have to go through and do it. So we would have 3t, nope, t cubed plus t squared I plus 3 halves t squared minus 6t j plus 3 halves t the fourth plus 5/3 t cubed minus 4t plus c. So I guess I could have gotten 2 on there if I wasn't so absurdly sloppy, but kind of a sloppy person when it comes to this tablet. I love the tablet. I think it's a great invention. All right, we're going to work on B now. So here's the first thing we want to calculate. So to do that, we're going to end up with I, J, K. I might have to spread these back out. I don't know. T squared, T cubed, T cubed, T squared, T. Right? End up with T squared times T minus T cubed times T squared I minus T squared minus T cubed J plus T times T squared minus T squared times T cubed K. Right. Bring that together and we get T cubed minus T to the 5th I minus T squared no, they switched it around. They brought the negative in. So they did plus T to the 6th minus T squared J plus T cubed minus T to the 5th. Okay. All right, so next we're gonna substitute everything back into the integral and integrate. So if you want to, you can rewrite that part if you want, but I'm just gonna go with the answer here. So the integral of T cubed minus T to the 5th I plus T to the 6th minus T squared J plus T cubed minus T to the 5th K. So that will give us an overall answer of T to the 4th over 4 minus T to the 6th over 6 I down J's plus T to the 7th. Writing way too fast for my own good here. Over 7 minus T cubed over 3J plus T to the 4th over 4 minus T to the 6th over 6K plus C. one more example for this problem set. This would be black. Yeah. All right, so we need to find the integral of sine 2ti plus tangent tj plus e to the negative 2tk dt from 0 to pi over 3. Okay, so I will write this out, but I'm just trying to figure out how much space we're gonna need. So I think I'm gonna go to the second step, and you guys will just need to know that if you want to rewrite, you can. We're going to break them apart, and it would be sine 2t from 0 to pi over 3 I minus, nope, plus dt integral. Ah, I was shoving two lines together. I apologize. What is my brain thinking? I. Tangent t dt j plus integral 0 to pi over 3 or e to negative 2 t dt. Okay. All right. Now we have to go through and do some work. So we'll have negative 1/2 cosine 2t from 0 to pi over 3. That's where I was shoving stuff in. I plus, nope, minus the ln of the cosine of t from 0 to pi over 3 j. Another eight minus minus 1/2 e to the negative 2 e 0 to pi over 3. Okay. All right, and now you're gonna plug everything in. So you have minus 1/2 cosine 2 pi over 3 plus 1/2 cosine of 0 pi minus the ln of the cosine pi over 3 minus the ln of the cosine of 0 j minus 1/2 e to the negative 2 pi over 3 minus 1/2 e to the negative 2 times 0. Okay. Alright. Then that works out to be 1/4 plus 1/2 I minus a minus 2 ln. Nope. Minus the ln of 2j minus 1/2 e to negative 2/3 minus 1/2. Okay. So I do recommend if you are going through with fractions to just be really careful that you know when they're a whole fraction versus when they're up top in the exponent spot. Plus 1/2 e. They flipped it around. Hmm. They didn't add their plus c. We're going to. Okay. That is all for section 3.2. I am going to pull open 3.3 just to see if we can get started with it. We probably won't get that far on it. It's 18 slides. I'm actually okay if that is the day. So let me stop the recording.